For wiring a 60 amp condensing unit on a residential pitched roof, the recommended wiring method involves using liquid-tight flexible metal conduit, or LFMC, with a disconnect mounted on the roof. This approach offers flexibility, protection, and code compliance. Here are the steps involved. Firstly, run the LFMC from the electrical panel to the roof, routing it through the nearest wall or attic space. Secondly, install a disconnect switch on the roof near the condensing unit. The disconnect should be rated for 60 amps and have a rain-tight enclosure. Thirdly, continue the LFMC from the disconnect switch to the condensing unit. Fourthly, connect the LFMC to the electrical terminals on the condensing unit. Fifthly, secure the LFMC to the roof using straps or brackets. Additionally, protect it from damage with conduit bodies or other protective measures as necessary. Using LFMC provides several benefits. Firstly, flexibility. LFMC can easily navigate roof angles and obstacles. Secondly, protection. The metal conduit offers protection from weather, physical damage, and rodent damage. Thirdly, code compliance. LFMC meets the requirements for wiring outdoor equipment on a pitched roof, specifically National Electrical Code, NEC, Section 350. There are reasons why rigid conduit is not recommended for this application. Firstly, difficulty installing. Rigid conduit is difficult to bend and maneuver on a pitched roof. Secondly, potential for leaks. The roof penetration for rigid conduit can be susceptible to leaks if not properly sealed. It's important to note that NEC 350 prohibits the use of rigid conduit for outdoor equipment on a pitched roof unless it is encased in concrete or protected by a raceway. Therefore, LFMC is the preferred and recommended wiring method for this application. The use of liquid-tight flexible metal conduit, or LFMC, provides a robust and code-compliant solution for wiring a 60 amp condensing unit on a residential pitched roof. By following the outlined steps, you can ensure a safe and effective installation. Remember to always consult the latest edition of the National Electrical Code, or NEC, and local electrical codes for specific requirements in the area. If you are unfamiliar with electrical work, it is recommended to hire a qualified electrician to perform the installation. They will have the expertise and experience to ensure that the wiring is done safely and correctly, complying with all applicable regulations. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years to reflect the latest advancements in technology and safety practices. Electrical inspectors use the NEC to ensure that electrical installations are safe and code compliant. Section 350 of the NEC specifically addresses flexible metal conduit, including liquid-tight flexible metal conduit, or LFMC. It outlines the permitted uses, installation requirements, and other relevant information for this type of conduit. When wiring a condensing unit on a roof, it is important to consider the environmental factors that the wiring will be exposed to. The wiring must be able to withstand weather conditions such as rain, snow, and sunlight. It must also be protected from physical damage and rodent damage. LFMC provides excellent protection against these factors. The flexibility of LFMC is particularly important when working on a pitched roof. The angles and obstacles on the roof can make it difficult to install rigid conduit. LFMC can be easily bent and maneuvered to navigate these challenges. When installing a disconnect switch on the roof, it is important to choose a disconnect that is rated for the appropriate amperage and voltage. It should also have a rain-tight enclosure to protect it from the elements. The disconnect switch should be located near the condensing unit for easy access. This allows technicians to quickly disconnect power to the unit for maintenance or repairs. When connecting the LFMC to the condensing unit, it is important to use the correct fittings and connectors. These fittings should be rated for use with LFMC and should provide a watertight seal. The connection should be made securely to prevent loose wires and potential electrical hazards. Securing the LFMC to the roof is also important. Straps or brackets should be used to support the conduit and prevent it from sagging or becoming damaged. The straps or brackets should be spaced appropriately to provide adequate support. In addition to the steps outlined above, There are a few other considerations to keep in mind when wiring a condensing unit on a roof. Firstly, ensure that the wiring is properly grounded. Grounding is essential for safety and helps to prevent electrical shock. Secondly, use the correct size wire for the amperage of the circuit. The wire size must be large enough to handle the current without overheating. Thirdly, protect the wiring from physical damage. Use conduit bodies or other protective measures to shield the wiring from sharp edges or other potential hazards. By following these guidelines, you can ensure a safe and code-compliant installation of a 60-amp condensing unit on a residential pitched roof. Remember to always consult the latest edition of the National Electrical Code, or NEC, and local electrical codes for specific requirements in your area. If you are not comfortable with electrical work, it is always best to hire a qualified electrician. They have the knowledge and experience to get the job done right. The NEC provides detailed information on conduit fill, which refers to the maximum number of wires that can be installed in a conduit of a given size. It's crucial to adhere to the conduit fill requirements to prevent overheating and ensure proper ventilation of the conductors. Table 310.15. B16 of the NEC provides ampacity ratings for various wire sizes and insulation types. Use this table to select the appropriate wire size for the 60-amp circuit, considering the ambient temperature and other relevant factors. When running the LFMC through the attic space, ensure that it is supported at appropriate intervals as specified by the NEC. This prevents the conduit from sagging and potentially damaging the conductors inside. Use listed connectors and fittings specifically designed for LFMC to ensure a secure and watertight connection. Avoid using generic fittings that may not provide adequate protection against moisture and corrosion. When installing the disconnect switch, mount it on a sturdy surface that can support its weight and withstand the effects of weather. Consider using a backboard or mounting plate to provide additional support if necessary. Label the disconnect switch clearly to indicate its purpose and the equipment it controls. This helps to prevent accidental disconnection of power to the condensing unit. After completing the installation, thoroughly inspect the wiring and connections to ensure that everything is secure and properly installed. Use a multimeter to verify the voltage and current readings at the condensing unit to ensure that it is operating within its specified parameters. Keep a record of the installation, including the wire sizes, conduit types, and disconnect switch ratings. This information may be useful for future maintenance or repairs. The location in Maine might experience harsh winter conditions, so ensure that all outdoor components are rated for cold weather use. This includes the disconnect switch, conduit, and any other exposed electrical equipment. Regularly inspect the wiring and connections for signs of damage or deterioration, especially after severe weather events. Replace any damaged components promptly to prevent potential hazards. If you plan to install the condensing unit on a roof with a steep slope, take extra precautions to ensure your safety. Use appropriate fall protection equipment, such as a safety harness and lanyard, and work with a helper if possible. Consider the aesthetic impact of the wiring and conduit on the appearance of the roof. Try to route the conduit in a way that minimizes its visibility and blends in with the surroundings. When penetrating the roof with the LFMC, use a sealant specifically designed for roofing applications to prevent leaks. Ensure that the sealant is compatible with the roofing material and the conduit. If the condensing unit is located near trees or other vegetation, trim back any branches that could potentially come into contact with the wiring. This helps to prevent damage to the wiring and reduces the risk of electrical hazards. Consider installing a surge protector at the electrical panel to protect the condensing unit from voltage spikes caused by lightning or other electrical disturbances. This can help to extend the lifespan of the unit and prevent costly repairs. If you are unsure about any aspect of the installation, consult with a qualified electrician or electrical inspector. They can provide guidance and ensure that the installation meets all applicable codes and standards. Remember that electrical work can be dangerous, and it is always best to err on the side of caution. The NEC is not intended as a design specification or an instruction manual for untrained persons. Its purpose is to provide minimum safety standards for electrical installations. Always follow the manufacturer's instructions for the condensing unit and any other electrical equipment used in the installation. The manufacturer's instructions may provide additional information or recommendations that are not covered in the NEC. Consider the long-term maintenance requirements of the electrical installation. Choose components that are durable and easy to maintain, and provide access points for future inspections and repairs. If you are planning to install multiple condensing units on the same roof, coordinate the wiring and conduit runs to avoid conflicts and ensure a clean and organized installation. Use color-coded wiring to easily identify different circuits and conductors. This can help to prevent confusion during future maintenance or repairs. Take photographs of the completed installation for your records. This can be helpful for troubleshooting or future reference. Consider the energy efficiency of the condensing unit and the electrical installation. Use energy-efficient components and wiring practices to minimize energy consumption and reduce utility costs. If you are planning to install a new electrical panel to accommodate the condensing unit, ensure that it is properly sized to handle the additional load. The panel should have enough available breaker spaces to accommodate the new circuit and any future expansion. When working with electrical wiring, always to energize the circuit before making any connections or modifications. Use a voltage tester to verify that the circuit is energized before proceeding. Wear appropriate personal protective equipment such as safety glasses and gloves when working with electrical wiring. This helps to protect you from potential hazards such as electrical shock and arc flash. If you are working in a confined space, ensure that there is adequate ventilation to prevent the buildup of hazardous gases. Follow all applicable safety regulations and guidelines when working with electrical wiring. Failure to do so could result in serious injury or death. Remember that electrical work is not a do-it-yourself project for untrained individuals. If you are not qualified to perform electrical work, hire a licensed electrician to do the job for you.